You're about to take a journey from the smallest thing in the universe to the largest. Each step is roughly 10 times bigger than the last. By the end, your sense of scale will be permanently broken. Let's start small. At the smallest scale we can measure, roughly 1/1000th of a meter, we find quarks. These are the building blocks of protons and neutrons, which make up the nucleus of every atom. A quark is so small that if an atom were the size of Earth, a quark would be the size of a grapefruit. Zoom out slightly and you reach the proton, made of 3 quarks bound together by the strong nuclear force. The proton is about 1.7 femtometers across, 1/1,000,000th of a nanometer. This is the domain of quantum mechanics, where particles can be in 2 places at once and nothing behaves like you'd expect. Zoom out to 1/10,000,000,000th of a meter, the angstrom, and you see the atom. A hydrogen atom is about 1 angstrom wide. But here's the unsettling part. Atoms are almost entirely empty space. If the nucleus were a marble placed at center field in a football stadium, the nearest electron would be miles away in the next city. Everything in between is nothing. The sensation you feel when you touch a table is electromagnetic repulsion between electron clouds, the closest you can get before quantum forces push back. Combine atoms and you get molecules, water, DNA, proteins. A single DNA molecule, if stretched out, would be about 2 meters long, packed inside a cell nucleus just 6 micrometers across. A typical human cell is about 10 micrometers, 100,000th of a meter. Inside it are organelles, mitochondria generating energy, ribosomes building proteins, the endoplasmic reticulum folding them into shape. Your body contains roughly 37 trillion of these cells, each one running thousands of chemical reactions every second. Zoom out further, past tissues, past organs, and you reach the scale of a human being, about 1.7 meters, standing on a planet that's 12,142 kilometers across. You are the middle point of this journey, roughly halfway between the smallest and largest things in the universe on a logarithmic scale. Earth is about 12,842 kilometers in diameter. The Moon orbits at an average distance of 384,400 kilometers, about 30 Earth diameters away. You could fit every planet in our solar system in that gap. Light takes 1.3 seconds to travel from the Earth to the Moon. That seems fast until you realize the scale is about to explode. The Sun is 150 million kilometers from Earth, 1 astronomical unit. Light takes 8 minutes to make this trip. Jupiter is 5 AU away. Neptune is 30 AU. The Voyager 1 spacecraft, launched in 1977, traveling at 17 kilometers per second, is currently about 165 AU from the Sun, and it still hasn't left the solar system. The heliopause, the boundary where the Sun's influence ends, is roughly 120 AU. Beyond that, interstellar space. And the nearest star? 4 light-years away. That's about 270,000 AU. If the solar system were the size of a quarter, the nearest star would be a football field away. Our galaxy, the Milky Way, is about 100,000 light-years across and contains between 100 billion and 400 billion stars. Our solar system sits about 26,000 light-years from the center in a minor arm called the Orion Spur. It takes light 100,000 years to cross the galaxy. The fastest spacecraft ever built, the Parker Solar Probe at 700,000 km/h, would take over 150 million years to cross it. And our galaxy has a supermassive black hole at its center, Sagittarius A Xerxes, 4 million times the mass of the Sun. Every star you see in the night sky is in our galaxy. Everything beyond is invisible to the naked eye. The Milky Way is not alone. It's part of the local group, a cluster of over 80 galaxies spanning about 10 million light-years. The nearest large galaxy, Andromeda, is 2.5 million light-years away and heading toward us at 110 kilometers per second. In about 4.5 billion years, it will collide with the Milky Way. Beyond the local group are galaxy clusters, collections of hundreds to thousands of galaxies bound by gravity. The Virgo cluster contains over 2,000 galaxies. These clusters connect into filaments, vast threads of galaxies stretching across hundreds of millions of light-years, forming the cosmic web. The observable universe, everything we can theoretically see, is 93 billion light-years in diameter, It contains hundreds of billions to potentially 2 trillion galaxies, each with hundreds of billions of stars. The cosmic microwave background, the oldest light in the universe, was emitted 380,000 years after the Big Bang, 13.8 billion years ago. It's been traveling toward us ever since, stretched by the expansion of space into microwave radiation. And the universe is expanding. The most distant galaxies are moving away from us faster than the speed of light, not because they're moving through space that fast, but because the space between us is stretching. There are regions of the universe whose light will never reach us. The universe is larger than we can ever observe. You just traveled 60 orders of magnitude, from 10 to the negative 18 meters to 10 to the 27 meters, from particles that are almost nothing to structures that span billions of light years. And in the middle of all of it, on a rock orbiting an average star in a quiet arm of an ordinary galaxy, there's you, made of atoms forged in dying stars, assembled by 4 billion years of evolution, aware enough to contemplate your own insignificance. The universe doesn't know it exists, but you do, and that might be the most remarkable thing at any scale.